There's more to the universe than meets the eye. So NASA is going to launch an observatory called NuSTAR to see some of the things we've been missing. NuSTAR stands for Nuclear Spectroscopic Telescope Array, and it's designed to give astronomers unprecedented looks at some of the highest energy objects in the universe, from stars that recently exploded to black holes.
And we are going to open up the high energy window on the universe. NuSTAR is going to teach us fundamental things about the universe, from what heats the corona of the sun or the atmosphere of the sun, to understanding black holes distributed across the universe.
One of NuSTAR's goals is to count the black holes in the universe, a survey that has never been done before and is expected to reveal a new scale for the cosmos.
We think that 2 out of 3 black holes in the universe are hidden.
Instead of looking at visible light the way a traditional telescope does, NuSTAR is equipped with specialized equipment that will see what are known as hard X-rays. Produced by extremely violent events in the universe, hard X-rays are similar to the X-rays dentists use to look into teeth.
And so it's much like Galileo 400 years ago was the first person to focus visible light with his first telescope. NuSTAR is the first instrument that's going to focus high-energy X-ray light. And this buys us more than 10 times sharper images, more than 100 times more sensitive pictures, and allows us to study some of the most energetic phenomena across the universe.
For as big a task as it's taking on, the NuSTAR Observatory is not very large.
Compared to a Juno or an MSL, it's a lot smaller. It is about 350 kilograms, about the size of a refrigerator, or a little less. And it's compact, but it only has one basic instrument on the spacecraft itself, where other spacecraft, the larger ones, have multiple instruments on them.
A Pegasus rocket, the smallest available to NASA's Launch Services program, is to lift NuSTAR into Earth orbit.
Pegasus is our most unique rocket, period. If you take a look at it, it's got a wing on it, which, the rest of our ELV launch vehicles don't. The next thing you notice is it's hanging off the bottom of an L-1011 carrier aircraft, which is quite unique also. And then to top it off, the way we launch it is we drop it just like you would a weapon or a bomb. And then this thing lights off 5 seconds later and scoots in front of the L-1011. It's unique in all kinds of aspects.
Launching from an airplane adds another aspect of critical timing for the launch team to consider.
You got to be at the right place at the right point at the right time, and everything's got to mesh to be able to do that correctly. So as far as my launch director role in keeping the team in sync and so forth, this is our most challenging type of mission. It's also one of our funner type missions because of that.
The NuSTAR spacecraft will launch from an island in the Pacific Ocean called Kwajalein, part of the Ronald Reagan test site.
So NuSTAR has some particular requirements to be around the equatorial orbit so they can do observations of the science they want to perform. Well, Kwajalein is not really a launch site. It's more of a receive kind of type of site, where with the Pegasus, we're taking in on L-1011, we're bringing the rocket to them, and we'll go off and we'll fly it off the L-1011.
Once flying on its own in orbit, NuSTAR will deploy a solar array to produce power. Later, NuSTAR will extend a 33-foot-long span with sensors on one end that will capture X-rays so astronomers can see what's out there.
And we have a set of planned observations of things that we're very safely sure we're going to see. But the big excitement is we might see things that are unexpected. We're going to have to keep our eyes open to see things that we weren't expecting to see.